Hi everybody, let's get back to the lab EL224 Diode Characteristic English version series 2. Um, there were, as I mentioned before, for the lab you need to do three parts. One is there, you work on two regular diodes. That's the 1N914, 1N4148. And you need to do a forward bias and reverse bias for both of diodes, and you need to take the data for V cut in or V on, forward resistance or that are forward or RF, leakage current I0, and V breakdown. That's the V break. For part 2, you just work so for this one you work on at the room temperature, work on circuit at the room temperature 27 degrees Celsius. For part 2, you need to work on 85.7 degree Celsius temperature. For the last one, you pick up a zero diode 1N5819 and work on room temperature 27 degrees Celsius. And I'm looking for 10 plots and 3 tapers. In your report. Okay, let's get started. The circuit. Well, this is a simple circuit. You have a 100 ohm resistor in series with the 1N4148 diode. And for the DC, for the supply voltage, you need the DC voltage. Okay, and this one represents .DC. That's you mean you want to do a DC sweep. Okay, let's just get back to setup. You go to PSPICE analysis and you pick up a DC sweep, because for the x-axis that's going to be the voltage drop across the diode, or VD, and for the y-axis that's going to be ID, or the current flowing through the diode. You will start with the DC supply voltage from 0 and stop at 100 volt, or you can do like 20 volt. This is the forward bias, and as you know, the diode is going to work just like close switch, and that when you have a supply voltage enough, the diode will close, will be just like close switch and allow the current to flow. And 0.02, that's the increment. You can just put 1, no problem. So I just want to work on I don't need 100. No, I can do 100, whatever, and for silicon diode, that we on about 0.7 volt. 100 ohms, my proposal is just I want to do extrapolate, to look for the cut in or V on. Just click OK, and you put the details, right here. And don't forget to label your output. So this one, you simply put cursor, on the wire, and you right click and just put on the label net, and you put VT. Okay. And this is V1. You can start with the 1N914. Simply put cursor on the components and right click, and you'll pick up new diode. That's the I need IN 914. Oops, where's that? And this nice about, oops, cancel. I don't know what's wrong. Oh, okay, here. Pick new diode. This doesn't matter. Okay, just use the 1N4148. And what a nice thing about this, you can see the breakdown voltage. Okay, you can double check again if whatever you have is correct or not. I'm not sure. It's just gone. Just now I just can see. Okay. This is detail about our diode 1N4148. Type is the silicon, and the V breakdown is that they're actually a negative 75 volt, and I averaged 0.20. Okay, that's the something like a data sheet. Okay, this one is not active. Okay, now everything's be ready to be simulate. So you click run, and you look for ID. You go to trace icon, and you put ID1. That the voltage something. Okay, the voltage. Something wrong with the circuit. The program again. All right, just paused for. Okay, finally, you have the plot, but this is very important for the x-axis. You look for the voltage drop across the diode, or VD, because you're working on diode equations. So this one needs to be your VD, sorry, in your circuit. The voltage drop across the diode is the VD, right? So you need to change your scale on the x-axis to be your VD voltage drop. So what you can see, you go to put the cursor on the x-axis, and then you right click. Actually, you can, let's see. Nope, that's the cursor. Sorry, hold on a second. You right click, and you can see that the quantity plot. This is the horizontal axis, or x-axis. What you need to do, you just put V, that's the format, and bracket, and VD, and also bracket. Yes, this is your ID and VD characteristic as the plot. The first one, you look for the V cut in or V on. What you can do, you can go to put that dash line over your plot. You can go to the main menu, plot setting, and go to notes and annotations. You put the draw line. Okay, we go to click and put dash line on the plot. This there. Okay. And where the dash line cut the x-axis, that's going to be your V cut in or V on. You need cursor, so just double click on ID1. Okay, and you can see that you can move the vertical dash line of your cursor, go to the x-axis, cut down right here, And this simply is the xy coordinate. Horizontal is going to be your voltage, right, x, and vertical, that's going to be your y, or the current flowing through the diode. So you can see here your cut-in voltage is about 838.1 millivolt. Okay. Next, I need a voltage right that you need to put in the table, just right here. We already have V cut in. Now next one is the forward resistance, or F. As I talked about it before, the slope of the line, the dashed line here, over the ID-VD plot, simply delta I over delta V, right? But for Ohm's law, V equal to IR, or R equal to VOI, that's going to be 1 over slope. 1 over slope, that's going to be your forward resistance, or internal resistance when your diode is on. Well, this one you need 2 cursor, but only cursor 1 active. You can reactivate cursor 2 by double click on ID1 again. Okay, as you can see now your cursor 2 is there activate. And you know how to find the slope. You just go to the dashed line. That's in the part over your ID-VD plot. As you can see down here, that's show the difference of the coordinate xy of cursor number 1 and cursor number 2. So this is the delta horizontal, that's the delta VD, right? And this one is the delta ID, that's vertical. So for your forward resistance, you simply do delta V over delta I. So that's going to be your 300.86 over 471.96 milliamp. Okay, that's you have forward resistance. Next, okay, let's kill the cursor. Next one is you need to do reverse bias. Look for leakage current and the breakdown voltage. What you can do, you can go back to your circuit. Okay, and we're going to do the reverse bias. So right click on here, we start 0. Stop value, I'm going to put negative 500 to see. And increment, I don't need 0.02, I can just put 1. Okay, you're working on a program anyway. You click OK. This is going to be your reverse bias. Now you do simulation, and you go to the plot. As you can see, 0 start from here, your supply voltage, and then on the most left, that's the negative 500 volt as you set up the sweep voltage in your circuit. As you can see here, for the leakage current, this is the 0, right? That's in the order of nanoamp. That's very small. You can pick up anywhere to read for the leakage current. Okay, and this one I don't see here the breakdown voltage. I don't know what's wrong. For the breakdown voltage, as I talked about that before, the way you can see is supposed to be like this, right here. You see that? For you, when you supply the negative voltage, and then finally it's going to hit breakdown voltage. That means you cannot use your diode anymore. It's crash, and then the diode work just like close switch or allow current to flow through the diode, which is not supposed to be like that. Okay, that's your first circuit. The next one is let's just kill this one. You work on the other diode, 1N914, and don't forget you work on 27 degrees Celsius temperature. Okay, part 2, you simply work on the temperature at 85 degrees Celsius. What you can do is that you can go to edit and then SPICE directive, and you just put .temp 85. That's mean you need to work on the 85 degree Celsius temperature. Okay, and you just do the same thing, do simulation, both forward bias and reverse bias. You have another 4 plots and another 1 table. Next one, you work on Zener diode. That's part 3. And the number is the 5819. Okay, which I have right here, and you just work on 27 degrees Celsius temperature. Okay, and you need to record. We cut in. I forward this resistance RF, leakage current I0, and the breakdown voltage. That's the V break. You have another 2 plots and 1 more table. So total you have 3 tables and 10 plots to submit or to add into your report before you submitting to me. Okay, that's all about our diode characteristic LTSPICE simulation.